Good day everyone, here's our math challenge for today. And here's our question. Solve for the value of x given this equation. Square root of 2 minus x equals 2 minus x squared. Here's a gentle reminder. Always check your final answer. Now, if you want to try this problem, just pause this video. We have 20 seconds and timer starts now. Time's up. Now let's answer this question together. Our goal in this question is to solve for the value of x. So given this equation, square root of 2 minus x equals 2 minus x squared. Now the question is, how are we going to answer this question? So we will do the normal way. So since we have a radical sign on the left hand side of our equation, so let's square on both sides. Now square root of 2 minus x raised to 2 will give us 2 minus x, while 2 minus x squared raised to 2, if we expand this, we get 4 minus 4x squared plus x raised to the 4th power. Now let's combine like terms. Let's subtract 2 on both sides. And then let's rearrange some terms a little bit. So we have an equation x raised to the 4th power minus 4x squared plus x plus 2 equals 0. Now let's focus on this equation. So our goal now is to solve for the value of x in this quartic equation. Now this is hard to factor, so we will use synthetic division. Now in synthetic division, we need the numerical coefficients of these terms. So we have x raised to the 4th power, the coefficient is 1, x squared is negative 4, x is 1, and we have a constant of 2. Also take note that when we use synthetic division, make sure that the exponent of x is in decreasing order. So we have x raised to the 4th power, we have x squared and x. Notice that we don't have x raised to 3. So let's put 0x cubed. So now we have x raised to the 4th power, x cubed, x squared, x, and constant. At this point, we are now ready to use the synthetic division. Now since it is a monic polynomial, so what we're going to do is to get the factors of the constant. So we have the constant of 2, and the factors of 2 must be positive and negative 1, and positive and negative 2. Thus, we have 4 possible choices to put in this half box. So our first choice must be 1. So let's have the synthetic division. First thing to do is to bring down the first number. And then 1 times 1 will give us 1. 0 plus 1 is 1. 1 times 1 will give us 1 again. Negative 4 plus 1 will give us negative 3. Negative 3 times 1 is just negative 3. 1 plus negative 3 will give us negative 2. Then negative 2 times 1 will give us negative 2. Now for the last entry, 2 plus negative 2 is just 0. Meaning that x equals 1 is a solution to this equation. Now let's continue. This is called continuous synthetic division. Now again, we choose 1 on the first, so let's choose negative 2 on the second. So we do the same thing. Let's bring down 1. 1 times negative 2 is negative 2. We put the negative 2 right here. 1 plus negative 2 will give us negative 1. Then negative 1 times negative 2, we have positive 2. Negative 3 plus 2 will give us negative 1. Then negative 1 times negative 2 will give us positive 2. And for the last entry, negative 2 plus 2 is just 0. It follows that x equals negative 2 is also a solution to this equation. Now at this point, our last entry must be 1, negative 1, and negative 1. Now if we choose negative 1 or positive 2, this will not give us 0 as a result. Therefore, we don't get any rational solution to this remaining factor. So this will force us to use another method to solve for the remaining values of x. So let's continue. We know that x equals 1 is a solution to this equation, and x equals negative 2 is a solution also to this equation. Now, given that x equals 1 is a solution, it follows that x minus 1 is a factor of this quartic equation. Also, x plus 2 is a factor of this equation. Now, the question is, what is the other factor? Now, in this remainder, we have negative 1 as constant. This negative 1, we can put x in this part, and we can put x squared on the next term. So the other factor must be x squared minus x minus 1. Therefore, we can say that x raised to the 4th power minus 4x squared plus x plus 2 can be factored as x minus 1 times x plus 2 times x squared minus x minus 1. Now at this point, let's solve for the values of x. On the first factor, if we equate this to 0, we know that x equals 1 is a solution for this equation. On the second factor, we also know that x equals negative 2 is also a solution to this equation. We get these two results using synthetic division. Now, how about in this factor? X squared minus x minus 1. If we equate this to 0, notice that this equation is related to the golden ratio. Therefore, if we use quadratic formula to this equation, we get that the value of x must be 1 plus square root of 5 over 2 or 1 minus square root of 5 over 2. And now, we have 4 possible values for x. Namely, x equals 1, x equals negative 2, x equals 1 plus square root of 5 over 2, or x equals 1 minus square root of 5 over 2. Now, as always, if we have a radical equation, always check your final answer. So first, let's check if x equals 1 is a solution to this equation. So what we're going to do is to replace all x with 1. Now, let's simplify. 2 minus 1 is just 1. 1 squared is just 1, so 2 minus 1 squared is also 1. And as you can see, square root of 1 is just 1. Therefore, x equals 1 is definitely a solution to our equation. Now at this point, let's see if x equals negative 2 is also a solution to this equation. So let's replace all x with negative 2. So we have 2 minus negative 2 equals 2 minus negative 2 quantity squared. Now 2 minus negative 2 will give us 4. And then negative 2 squared is also 4. Now, 2 minus 4 will give us negative 2. Now, since we take the principal root of square root of 4, therefore, the left-hand side is equal to 2. So, 2 is not equal to negative 2. Therefore, negative 2 is not part of our solution. So, let's check the third value for x. We have 1 plus square root of 5 over 2. So, let's replace all x with 1 plus square root of 5 over 2. Now at this point, we will use some approximation. 1 plus square root of 5 over 2 raised to 2 will give us a value that is greater than 2.6. Now 2 minus 2.6 is definitely a negative number. Now since we need to take the principal root of the left hand side, therefore this is positive and the right hand side is negative, thus 1 plus square root of 5 over 2 is also not part of our solution. Now at this point, let's check the last possible value of x. So let's replace all x with 1 minus square root of 5 over 2. Now let's simplify first the number inside the radical sign. Now 2 can be written as 4 over 2. Now since they have the same denominator, we can subtract them. So we have 4 minus 1 plus square root of 5. Now 4 minus 1 is just 3. Now how about on the right hand side? 1 minus square root of 5 over 2, if we square this, we get 1 minus 2 square root of 5 plus 5 all over 4. Now, 1 plus 5 is just 6. And this 2 can be written as 8 over 4. Now, we have the same denominator, we can subtract them. If we do that, we get 8 minus 6 plus 2 square root of 5. Now, 8 minus 6 is just 2. Now, let's factor out this 2 on the numerator. And 2 divided by 4 will give us 1/2. Now the final question is, are they equal? To show that the right-hand side is equal to the right-hand side, what we're going to do is to get the square root of this term and then square it. So square root of 1 plus square root of 5 over 2 quantity squared is just 1 plus square root of 5 over 2. Now let's square 1 plus square root of 5 over 2. If we do that, we get 1 plus 2 times square root of 5 plus 5 all over 4. Now 1 plus 5 is just 6. Now factor out 2 on the numerator, we get 2 times 3 plus square root of 5 over 4. Now 2 divided by 4 is just 1/2. Now as you can see, the left hand side now is equal to the right hand side. Therefore, this 1 minus square root of 5 over 2 is also a solution to our equation. Therefore, we found two possible solutions to this equation. Square root of 2 minus x equals 2 minus x squared. Namely, x equals 1 and x equals 1 minus square root of 5 over 2. And as always, we are done.